Hey, this is Mr. Janes. In this video, we'll be talking about measures of spread, things like range, interquartile range, and standard deviation. As you watch this, make sure to put away all distractions, pause the video and predict when you can, pause to rewind if you need to, and as always, please take notes the entire time. But first, what is spread? So a measure of spread tells us how similar or how varied the values in a data set are. Let me give you some examples. So a low spread is said to be consistent, regular, or precise, whereas data with a high spread is said to be variable, inconsistent, deviant, or wild. So, for example, a basketball player that is consistently getting the same score or similar scores every single game, they're going to be pretty consistent and have a low spread. Whereas basketball players that are variable or inconsistent, getting high scores and low scores all over the place, are going to have a high measure of spread. Now, a measure of spread has nothing to do with a measure of center, like an average. For example, if you're a basketball player, you can have a low spread and be very consistent, and be consistently high scoring and have high average, or consistently low and have a low average. So these have nothing to do with averages. They're all about whether you're consistent with a low spread or variable with a high spread. Now we have three ways of measuring the spread or the variability of a set of data called range, interquartile range, and standard deviation. Let's start by talking about the simplest one, range. Now the range is the difference between the maximum value and the minimum value of a data set. So all you need to do is find the maximum value and subtract the minimum value. Let's practice this. In the example problems, the first set asks us to find the range of the following three sets of data. Now remember, all you need to do here is find the highest value and the lowest value and subtract them. Pause the video now to try and find the range of the following three sets of data. The answers will be coming up in 3, 2, 1. When you have a list of numbers, it's pretty simple. Look through the list for the highest number, which is 33 in this case, and the lowest number, the minimum, which is 21, and subtracting 33 from 21, we have a range of 12. What about the next one? Well, again, dot plots aren't that bad either. The maximum value is the one farthest to the right, that's 32. And the minimum value is the one farthest to the left. Looks like it'll be 27. So I subtract those, 32 minus 27, and end up with a range of 5. So what about the third example, that frequency table? Well, in a frequency table, it's not so bad either. If we look here, in green, I've got the maximum value, which is 10, and the minimum value, which is 4. So 10 minus 4 gives us a range of 6. Remember, since this is a frequency table, and we're only looking at the maximum and minimum values, we don't actually care about the frequency part of it, how often each of those marks occurred. We only care about the highest and lowest value, 10 minus 4, to get a range of 6. So if we were to compare these three data sets together and say which one is the most spread out and which one is the least spread out, I would say this first one, with a range of 12, has the highest spread. Versus the second one with a range of 5 looks like it has the lowest spread. But is it really fair to judge the spread or the variability of a data set based on just the first and the last number? I mean, think about it. In this last data set over here, this guy got lucky on, looks like maybe a test he took, and got just 110. Or in the second one, it looks like there's an outlier here at 27. What if there are outliers? Should those count in a range? Luckily, there's a different kind of range called the interquartile range that takes away those outliers. Here's how it works. Now, the interquartile range is the difference between the first quartile of the data and the third quartile of the data. Now, that sounds really confusing, but basically what we're going to do is take our list of numbers and separate it into fourths or quarters. We're going to first cut it in half and then cut each of those halves in half. Then we're going to find the range between the first quarter and the third quarter, so getting rid of any outliers on the ends of our data. I'll show you how it works right now. So let's go down to the second set of example problems right here. Find the interquartile range for the following three sets of data taken from above. Now, if you notice, I'm actually going to use the same exact data sets as I did up here in the first problems, except I'm not going to use dot plots or frequency tables. What I've done is I've literally written out all of the numbers right here. Right? All of the numbers, the data from the dot plot are in the second example, and all of the data from the frequency table is in the third example. So the first step you need to follow is put the data in order. Now, if you notice, I've already done that for us. First example goes from 20 all the way up to 33. The second one is 27 all the way up to 32. And the last one is 4 all the way up to 10. All the data is in order. So like I said, we're going to have to break this data into quarters. But before we do that, we're going to break it in half. So step 2 is to find the median, or the halfway point, through our numbers. So the first data set has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So it's an even amount. So if I break it in half, there's going to be 5 on each side of the median. So 1, 2, 3, 4, 5. So the median should be right here between 23 and 25. And just to double check, 1, 2, 3, 4, 5. Yep, that line is exactly in the middle. So if I was finding the median, I'd have to find halfway between 23 and 25. But I'm going to stop there for this one. Let's try and do step 2 with the other 2 examples. Let's see, the second example has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. Since it's odd, my median is going to fall right on, I think, the 6th number. I think of 11, half of that's going to be 6 is going to be right in the middle. So 1, 2, 3, 4, 5, 6. That's my median right there. Let's double check. 1, 2, 3, 4, 5, 6. Yep, 31 right there is right in the middle. That's my median. What about the last example? Well, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, 20 data points. So it's an even number. So halfway will be right between the 10th and the 11th numbers. So 10 on each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my median, my halfway point is going to be between those two sevens. Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, 10 on each side. So remember, we said that we wanted to eventually break the data into quarters. Now we've broken all the data sets in half by finding the median. And so to find the quarters, we're going to take each half and break that in half. After all, half of a half is a quarter. So step 3 is to break the data into quarters by finding the median of each half of the data. In this first example, there are 1, 2, 3, 4, 5 numbers in the first half. So to find the median of that, let's see, half of 5, that'll be the third number in each direction. So 1, 2, 3, and 1, 2, 3. 22 is that middle number. So that is the first quarter number. So I'm going to call that Q1. On the other hand, the other half also contains 5 numbers. So that'll be the third number in, 1, 2, 3. Or 1, 2, 3. There it is. So 32 is almost like the third quarter, right? So I'm going to call that quarter 3. Let's do this for the next 2 examples too. In the second example, we've got 1, 2, 3, 4, 5 numbers, okay, in a half. So again, 1, 2, the third number. 1, 2, 3, yeah, so that's the middle number. That's going to be called the first quarter, or quarter 1. And then over here, 1, 2, 3, 4, 5 numbers. I mean, there should be the same on both sides. So 1, 2, 3, 1, 2, 3. There we go. So the middle number there is called the third quartile. And the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 numbers on each side. Now this is an even number. So think about where the middle of 10 numbers is going to be. It's going to have to be between the 5th and the 6th number. So if I count, 1, 2, 3, 4, 5. Okay, 6. Or 1, 2, 3, 4, 5. So there are 5 on both sides. Now normally, if I had 2 different numbers here, I have to do the same exact thing I do with a median. Add them together and divide by 2 to find the average. But it just so happens that these numbers are both 6. So the average of 6 and 6, my first quartile is going to be 6. On the other end, I've got another 10 numbers, so halfway will be between the 5th and 6th number. So 1, 2, 3, 4, 5, right there, 6. Or 1, 2, 3, 4, 5. Perfect. So I've got the middle right here. And again, since it's between 2 numbers, I would normally have to add them together and divide by 2. But since both numbers are 8, if I add 8 and 8 together, I get 16. Divide by 2, I get 8 again. So my third quartile is 8. Now the last step in finding the interquartile range is to find that range. Now in the beginning, we found the range by subtracting the maximum, or the highest number, from the minimum, the lowest number. But we said that sometimes there's going to be outliers on either end of our data that we don't want to include. So instead, we're going to find the interquartile range by subtracting the third quartile, or Q3 right here, from the first quartile, or Q1 right here, to eliminate those outliers on the ends. So for the first one, Q3 is 32 and Q1 is 22. So let's see, 32 minus 22 gives us an interquartile range of 10. For the second one, quartile 3 is 31 and quartile 1 is 30. Those are pretty close. So that means 31 minus 30 gives us an interquartile range of just 1. For the last one, the third quartile is 8 and the first quartile is 6. So 8 minus 6 gives us an interquartile range of 2. So to recap, to find the interquartile range, we first put the data in order. Then we found the halfway point, the median, in red here. Then we broke the data into quarters by finding the median of each of those halves in green for quartile 1 and blue for quartile 3. And once we found that quartile 1 and quartile 3, we subtracted them to get the interquartile range. Now remember, the point of all this is to find some sort of range that doesn't include the maximum and minimum, so it doesn't have any outliers in it. And after we did that, we can kind of tell that, hey, this second example here has a very, very low spread. It's very consistent. With outliers like 27 and 32, the range we're left with is just 1. Now, range took into account the highest number and the lowest number, the maximum and the minimum. The interquartile range did a little better by getting rid of those outliers, but it still only involved 2 numbers, quartile 1 and quartile 3. There's one kind of measure of spread called the standard deviation that takes into account every single number of the data set. Standard deviation is a statistic that measures the distance or deviation of every data point from the mean and is a good measure of the spread of a data set. Now, because it uses every single data point, the formula to calculate standard deviation is much more complicated than interquartile range and substantially more complicated than range. And because it's so complicated, we're not going to talk about it in this video. Instead, we'll use a calculator in class to calculate the standard deviation. But even though we're not going to calculate it by hand, it's still a good idea to understand which graphs or which data sets look like they have a higher standard deviation than others. In other words, which ones have a higher spread. Let's take a look at this third set of examples here. Order the following graphs from least to greatest standard deviation. Since standard deviation is a measure of spread, basically we're saying which one of these is the most spread out and which one of these is the least spread out. Pause the video now to try and figure that out. The answers will be up in 3, 2, 1. And here we are. If you notice, the data that's all clustered together like this has a very low spread. It's very consistent, and as a result, it's going to have the lowest standard deviation. On the other hand, this data on the end is very spread out, right? It's not as clustered together as the other one, so it has a very high variability or a high standard deviation. What about this last example here? Order the following graphs from the least to greatest standard deviation. Again, remember, standard deviation is a measure of variance. The more spread out something is, the higher the standard deviation. The more clustered it is, the lower the standard deviation. So, pause the video now and try and order them. The answers will be up in 3, 2, 1. So it turns out that this last one over here has the lowest standard deviation, the middle one has the highest, and this first one off to the left has a medium standard deviation. An important thing to remember about standard deviation is it's measuring how far all the data points are from the center. After all, that's what tells us how spread out something is. In this last one right here, most of the data points are pretty close to the center. It's nice and bell-shaped. On the other hand, the second one, most of the data points are far away from the center, right? It almost looks bimodal. So the deviation there is very high. It's very spread out. And this first example here, we kind of have a uniform set of data with some points closer to the mean while some are farther away. So it's going to have a moderate level of standard deviation, not as high or spread out as this middle one, but not as low or clustered together as this last one. Thank you for watching this video on measures of spread. Make sure to write down any questions you have, and we'll talk in class next time I see you.